Hello everyone, welcome to my channel, and we will continue today with amine chemical reactions. And in today's session we'll be discussing two reactions, that is reaction with nitrous acid and with aryl sulfonyl chloride. So please watch till the end. The first one is nitrous acid. Now what is nitrous acid? HNO2. Now first thing is we cannot use HNO2 as such because it is unstable. It is unstable. That is why we always prepare this in C2. In C2 means within the reaction we prepare it. It's a very important reaction to distinguish between alkyl. It is used to distinguish between alkyl amine and aromatic amine. That means I am talking about 1 degree. 1 degree alkyl amine with aromatic amine. In a way, I may write this as RNH2 and ARNH2. ARNH2. So it is used as a distinguished test for them. Now, what exactly we do here is, suppose we use RNH2. It's a primary amine, right? Now this is treated with HNO2. As I said, HNO2 you cannot use directly. You will be preparing it in C2 by using NaNO2 and HCl. Okay, at very low temperature you will be preparing this, and what you will get is HONO, that is HNO2, and what you will get here is RN2Cl. Yes, so you'll get R. I will explain you the mechanism separately. Just for basic understanding, I am telling you how you are going to learn this. Okay, so what you're getting is RN2Cl. That means it is called as alkyl diazonium chloride. So this is RN2 is for diazo group and chloride, and then now the product which is formed is hydrolyzed, means it is made to react with water. So now how will you write this? You draw two lines, you put OH here and H here. That is just for remembering how to write down the product. What you get is ROH, that is alcohol, plus what you have is N2, nitrogen gas is evolved, plus HCl. Okay. Now this is very important, that in this there is a liberation of nitrogen gas. If you are using alkyl amine, that is 1 degree alkyl amine, there will be a liberation of nitrogen gas, and moreover that diazonium which is formed here is not that stable, so it will get hydrolyzed very easily and you will get alcohol. It's a very important reaction. When we do the conversions, it will be required. Okay, now instead of alkyl, suppose I use here aryl. That means say I am using here as C6H5NH2. Okay, so what we have done is we have used here NaNO2, HCl 0 to 5 degrees Celsius. So what you get, first step, you'll get a similar product, only thing is instead of R it will be phenyl group. Now C6H5N2Cl. That means the product is phenyl. This is benzene. This will be benzene. It's not as a radical. It's benzene diazonium chloride. Benzene diazonium chloride will be obtained. Now you must be wondering why I did not hydrolyze it. You cannot hydrolyze it. So you cannot hydrolyze it to liberate, because this is very stable. You'll study later on in benzene diazonium chloride, diazonium salts, that this is resonance stabilized. So this cannot get hydrolyzed easily. Of course, in warm water we do say it will. But when you are asked to write as a distinguishing test, if you are asked to write a test between the two, you will write down HNO2 reaction. If it is this, that is alkyl, you will get diazonium salt which is not stable, gets hydrolyzed very easily, and you get alcohol, and nitrogen gas is evolved easily. Whereas if it is the aromatic thing, it will not get hydrolyzed easily because this is quite stable. And for secondary and tertiary amine, they react with nitrous acid, but that is in a different manner. That reaction we don't have in our syllabus. Okay, so now let me just explain it to you, the mechanism part of it. That means how you are getting this diazonium. Okay, so that I'm explaining. This is nitrous acid. Okay, there are two lone pairs of electron and oxygen. You're carrying out the reaction with this HNO2 is there, plus you have HCl also, right? So HCl will have H plus and this Cl minus. So there is a lone pair of electron over here on oxygen atom. So what happens is, first step, this will go here. I mean, it will pick this up H from here, and that H will get attached onto O. So what you get is O, N, O, only one lone pair left, one H, one H. Okay, that let it be a lone pair. I will attach this here and let this be now a positive charge. Oxygen now gets a positive charge. Okay, now basically this O with the positive will never be happy. So when O is a positive, I hope this part is clear. This is a lone pair and a positive. So when this is getting a positive charge, oxygen, it will try to take the electron from the neighboring. So when this goes here, so this part will now come out as water. So on the arrow, what you will write? Water molecule is eliminated. So what is formed in here? That I am writing down. So actually, let me write down here. There is space O, N, right? This is O, N, right? Now this O is having both the pairs. This is now having a positive charge because that has lost the electron. This is deficient. Okay, now this will be acting as a electrophile. This will be acting as a electrophile. So now what happens is, this amine, that is RNH2, this will react with, now I'm writing this reverse, okay, because this N is positive, through this it is going to get attached. So now what happens is, through this N, it will get attached to the neighboring N. So what you will have here, you will have here R, you will have here N, one H on the top I am writing, the another H, this I am opening it up. Through this N, it is getting attached, right? So this positive, don't get confused, was because it has lost the electron. Now on this particular nitrogen, there will be positive because it is having 4 bonds, right? Now again N getting a positive, that means it will take this electron back, right? It will take the electron back from here. When it takes back, this H plus has to come out. So that means that H plus will come out, and what you're left over with, R, N, one H is there, right? You have one single bond, N, double bond, O. Fine till here. Now what happens is, internally there will be a proton transfer. Now how there is a proton transfer? Now this, O is more electronegative, so this electron will go towards O. When this goes towards O, this N is deficient, it will try to pull electron from here. So now this H is positive, this is negative. So from this position, H will come and get attached here. From here, it will go and get attached here. In a way, I can say that there is proton transfer that is taking place. So what transfer has taken place? I am writing it now, R, N. This is now a double bond in between the two. This is single bond, O and H. Fine. Now this H had come out from here, right? This did not get attached anywhere. Now this O is having a lone pair, so that will definitely have a tendency to pull this H towards itself. So now in the next step, this H from here will come and get attached. So what you will have is R, N, double bond, N, this O. Now I think you are getting it, what is happening. Yeah. Oh, sorry. This was here. I think you can just check it. I missed out. Okay. So what happens is, this O will be now pulling that electron and it will try to come out as water. This will try to come out as water. When this will come out as water, what are we left over with? This is R, N, double bond, N. of course minus water molecule here. This N again is deficient because this has gone here. This is deficient. This N will have a lone pair of electron. Now what happens is, there was Cl minus also in the first step. So that Cl minus will get attached onto it. Right. Now before it gets attached onto it, what will happen is, internally this lone pair of the electron will go and shift this side. When this goes and shifts this side, what will happen? R, N, this will be a triple bond, this will be N, and this nitrogen will get a positive charge. This species will be here and Cl minus will get attached here. In a way, what you have got is alkyl diazonium chloride. Just see, in between I missed, pushing it up. Just see, I think you have followed or not. Let me repeat once again. This is the story we started with nitrous acid. First with HCl, it will pull this H. This goes here. This will come out as water because it shifts this side. It will come out as water. That I have written here. This is the electrophile generated. The next step begins from here. That electrophile now attacks the amine. It will take the lone pair of electron from here, will form this species. Now this H plus will come out. It is coming out from here. When it comes out, you will get this species. Then this O being more electronegative will pull electron toward itself, and internally there will be a proton transfer, because when this goes here, this is deficient, it will pull this side, H plus will be formed, H plus will attack O minus. So in the last step, that this proton transfer, this from here we missed it, right? So that proton has come this side. Now what happens is, this H plus which was generated over here, this H plus shifts this side, so when it shifts this side, you will get this species. So O getting positive, again this is ready to come out as water. This came out as water, you got this species. And in the last one, that lone pair on this nitrogen shift this side, make this a triple bond, and nitrogen the positive charge and Cl minus is generated. So where are we using this nitrous acid test, children? I told you this is used as a distinguishing test between aliphatic and aromatic amine. Aliphatic amine will give diazonium salt, which is not very stable. It will give out, nitrogen easily, and it will result in the formation of, alcohol. Whereas if I am using here aromatic, then it is stable. It will not give alcohol phenol readily. Okay, though with warm water we are going to study in this diazonium salts, it does give. Fine. Now let's continue further. Now let's consider the next one, that is C6H5SO2Cl. That is benzene. The name is benzene sulfonyl chloride. Now C6H5SO2Cl. Now how will this react? Now this is a very, very important test. You will use it to distinguish between 1 degree, 2 degree, 3 degree amines. How you will use it, that I am explaining it. Suppose I am starting with 1 degree amine. Now 1 degree amine, that is, this is 1 degree I am taking. I have taken ethylamine or ethanamine. Now I am using this with C6H5SO2. I am just opening this SO2 and Cl, right? So first step, what happens is, this Cl minus has to come out. What exactly happens is, this is more electronegative, it will pull this side. So due to back bonding, it will come, and that Cl minus will come out. So that Cl minus is coming out means through this sulfur. Sulfur is now getting positive to some extent. So this sulfur, through sulfur, it is going to get linked to N. So how it is going to get linked, I am writing here. You are getting here C2H5N. At both the hydrogens I am writing like this, and through S you are going to link this S double bond O, and this side you will be writing C6H5. Now this nitrogen, children, here is getting a positive charge because it's getting a triple bond. Now nitrogen again will not be happy to get this positive charge. So now what happens is, this will come back here, right? So this will come back, this H will come out. Why it will come out? Because this HCl and this H will come out as HCl. Right, so this has come out. What is left over? C2H5. Here it is N. Here there is one H only left over because one H has gone here. This is SO2C6H5. Now, what is the distinguishing test that I'm telling you? We write down here. This is further treated with alkali, that is base Na plus and OH minus. Now, what happens is this nitrogen is having a hydrogen attached. So nitrogen definitely is more electronegative, right? And so this is a acidic hydrogen. So this being acidic hydrogen will react with this OH minus and it will come out as water. When this will come out, this nitrogen will be deficient of the electrons. I mean, it will have the excess of electrons, not deficient, because this H plus has gone out. So this electron has gone on to N. So N got negative. So when N got negative, this Na will get attached onto N. So what you get is C2H5N. This is minus and on that Na plus will get attached. That means what you are getting is a salt. Right, so this is the product. In NCERT, how they are writing? If you use primary amine, you are getting reaction with benzene sulfonyl chloride. You get the product. This is the product in the first case. They have written like this. Here I have shown you that Cl comes in, then H also comes out, HCl comes out. Otherwise, directly one H and Cl we can remove it and write down. The product is obtained. Now, what is the product name? On N position there is ethyl. So we name this as N-ethyl benzene sulfonamide. Sulfonamide. This is the name. And they write in NCERT, it is reacting with it, forming N-ethyl benzene sulfonamide, which is soluble in alkali. Why it is soluble in alkali? Because it is having that acidic hydrogen. So when you are treating with this NaOH, this OH and H comes out as water and that Na ka salt will be formed. So you will write down it is soluble. 1 degree amine if you are using, the product is soluble in alkali. That is with NaOH. Fine. This is for 1 degree. Now the same thing if I write down here for 2 degree. I am writing in the same frame so that you understand. Now what we do is, now we are using for 2 degree. 2 degree means actually here you don't have much changes. Only the thing is, instead of 1 H you will have one more ethyl. So this is there. N, one lone pair will be there. 1 H only now. This is C2H5. We are making it react with C6H5SO2Cl. I am going the same way. Right. So I am just removing HCl. Now I am not going into that detail. 1 H and 1 Cl will come out and this will be there. I am writing this product directly. So what you will be getting? C2H5 and instead of this H, now what you will have is C2H5. Here you will have this SO2 C6H5. Now in this there is no H here. There is no H means it is not having any acidic hydrogen. Not having any acidic hydrogen means we will say if you are making it react with the secondary amine, the product is formed, that is NN diethyl benzene sulfonamide. The product that is formed here, the product that is formed is insoluble in alkali. It is insoluble. It is insoluble in alkali. Now why it is insoluble in alkali? You know, there is no acidic hydrogen. Suppose I am using here NaOH also. This will give OH minus, but there is no H to be replaced. So we say for 2 degree it is insoluble in alkali. Right? Now in this only, please note down. I will explain you here only if I am using 3 degree amine, then what will happen. Okay, noted. Now, suppose I am using 3 degree. Then instead of this H, also there will be C2H5. C2H5 means there will be no HCl coming out. This is going to pull electrons toward itself, fine, but there will be 3 alkyl groups attached here. This will not form a stable compound with this. So in case I am using tertiary amine reacting with benzene sulfonyl chloride, there will be no reaction. So what you will write, if you are using 3-degree amines with the benzene sulfonyl chloride, there will be no reaction. The distinguish is clear. This is a very, very important thing, and the name of this C6H5SO2Cl, this reagent is called as Hinsbergs reagent. It is Hinsbergs reagent. What is Hinsberg reagent? Benzene sulfonyl chloride. And how will you write the distinguish between test? You will write it as, if you are reacting with 1 degree, you get the product as N-ethyl benzene sulfonamide, which is soluble in alkali. If you are using 2 degree, you will get N diethyl benzene sulfonamide, insoluble in alkali. If you are using 3-degree amine reacting with Hinsberg's reagent, there will be no reaction at all. Fine till here. Okay, so children, we have completed the next 2 reactions also. That means now only one slot is left, that is electrophilic substitution reactions. So that I am going to cover in the next video. So with that, amine will be over, and then the diazonium salts I will be doing separately. So please stay tuned for the next lecture, that will be on electrophilic substitution reactions of amine. Thank you. Thank you for watching.